Hello, in this first video we will look at the Nobel Prize in Physiology or Medicine from 1901 given to Emil von Behring, dealing with the general idea why he got the prize. For instance, this is a quote from Wikipedia, for his work on serum therapy, especially in application against diphtheria, by which he has opened a new road in the domain of medical science and thereby placed in the hands of the physician a victorious weapon against this illness and death. This is from the official site from the Nobel Prize, where almost all information in this video is coming from. Here you can see the link to that. Why he got the prize? Well, many diseases are caused by microorganisms, but the body can use its immune system to defend itself against attacks and become immune to these attacks. As part of these defenses, the immune system forms antibodies that neutralize poisons or toxins that are formed by bacteria. Emil von Behring and other researchers showed that by means of blood plasma or serum, antibodies could be transferred from one person or animal to another person, who also then became immune. In 1900, Behring introduced the serum for immune horses as a method to cure and prevent diphtheria, which was quite a feat because it was a very dangerous illness at the time. Here you see him working with the horses. Also from the official Nobel Prize site, some biographical information. I have used quotes, but not the whole biographical section, only the parts I found relevant. Here it goes. Behring's most important researches were immediately bound up with the epoch-making work of Pasteur, Koch, Ehrlich, Lefebvre, Vezin and others, which led the formation of modern knowledge of the immunity of bacterial diseases. But he is himself chiefly remembered for his work on diphtheria and on tuberculosis. He is Behring. During the years 1888 to 1819, Roux and Ayezin, working at the Pasteur Institute in Paris, had shown that filtrates of diphtheria cultures which contained no bacilli contained a substance which they called a toxin that produced, when injected into animals, all the symptoms of diphtheria. In 1890, L. Brieger and C. Frankel prepared from cultures of diphtheria bacilli a toxin substance which they called toxalbumin, which when they injected in suitable dose into guinea pigs, immunized these animals to diphtheria. That's of course an important step. Starting from his observations on the action of iodoform, Behring tried to find whether a disinfection of the living organisms might be obtained if animals were injected with material that had been treated with various disinfectants. Of all, the experiments were performed with diphtheria and with tetanus bacilli. They led to the well-known development of a kind of therapy for these two diseases, which were very dangerous diseases at the time. In 1819, Behring and S. Kitasato published their discovery that graduated doses of sterilized broth cultures of diphtheria or of tetany bacilli caused the animals to produce in their blood substances which could neutralize the toxins which these bacilli produced. It's not the bacilli were killed, but the toxins they produced were eliminated. They also showed that the antitoxins just produced by one animal could immunize another animal, and that they could cure an animal actually showing symptoms of diphtheria. This great discovery was soon confirmed and was successfully used by other workers. Earlier, in 1898, Behring and F. Wernicke had found that immunity to diphtheria could be produced by the injection into animals of diphtheria toxin neutralized by diphtheria antitoxin. In 1907, Theobald Smith had suggested that such toxin-antitoxin mixtures might be used to immunize man against this disease. It was Behring, however, who announced in 1930 his production of a mixture of this kind, and subsequent work which modified and refined the mixture originally produced by Behring resulted in modern methods of immunization, which have largely banished diphtheria from the scourges of mankind. Very important step, of course, mean disease. Behring himself saw in his production of the toxin-antitoxin mixtures the possibility of final eradication of diphtheria, and he regarded this part of his effort as the crowning success of his life's work. Again, this comes from the biographical section on the official site, but in reality that's longer. So if you want to read it completely, follow the link. You see some of the materials used by Behring. There's also always an award ceremony speech. This for Behring was given by Count Müller. Also selected quotes from that. In reality it's longer. The year 1883 marks a turning point in the history of diphtheria. It had been assumed earlier by one or two workers that diphtheria was a disease which was caused by bacteria, but on the other hand it was contested by prominent experts, so it was unclear. Nothing positive was known, and there had been no scientific argument on the subject. Still less it could be said there was any certain knowledge of the kind of illness-producing parasites involved. In the above-mentioned year, Loeffler completed his comprehensive and extremely significant investigation of the bacteria of diphtheria. This investigation laid the foundations of further work developed of the study of diphtheria treatment. Because of Loeffler's works, Defoe was obliged to drop his mask and make known his battle tactics. Using his own weapons against him was to be reserved for later. In general, the disease-causing bacteria produces poisons, which in their turn give rise to a toxic condition individual in which they develop. And it can kill. And it is precisely because of these poisons that the bacteria are so dangerous. Nevertheless, it was shown that the poisons under certain conditions will lead the organism to produce substances which render them harmless, the poisons, and which prevent the development of the bacteria. And such a condition of immunity has been built, the individual can become insensitive to the bacteria in question and resistant to the poisons. Blood fluid or blood serum, it's the same, from an individual who has been immunized with poisons from a certain bacterium can, namely when introduced to the organs of another individual, confer resistance upon him against the bacterium in question. Upon this modern serum therapy is based, and that is the discovery, the breakthrough of Behring, of course. Up until now, serum therapy has had particularly splendid triumph in the case of diphtheria, but its significance is not limited to this disease, but extends much further. The field is open for research, but the development of serum therapy has, therefore, for the present, no discernible limits. Much ground has been gained already, and we justified expecting a great deal of important progress. As you can see, these are only parts of the speech. If you want to read the complete speech, follow the link. I have only selected quotes which I thought were relevant in this case. Here you see Behring on tuberculosis, other tuberculosis researchers on a sort of family picture. On the side of the Nobel Prize there's also a article on Emil von Behring, the founder of serum therapy. As you can see, it was based on an exhibition by Cornelia Grundmann, and the article is called Tetanus Therapeutic Serum during World War I. Dus until now we most talked about diphtheria, but now it's about tetanus. In 1891, tetanus serum was introduced considerably more quickly in clinical practices than the diphtheria serum. The Agriculture Ministry supported research efforts to develop a therapeutic agent against tetanus to protect agriculturally valuable animals. The large amount of serum required were obtained through the immunization of horses. However, there was no potential clinical testing on humans. This led the military administration to accept it only on a small scale at the beginning of World War I. The therapeutic serum developed by Behring prevented diphtheria for only a short time. In 1901, Behring therefore for the first time used the diphtheria inoculation of bacteria with reduced virulence, this new approach. With this active immunization, he hoped to help the body also produce antitoxins. As a supporter of the humoral theory of immune response, I'll come back to that in the second movie about his lecture, Behring believed in the long-term protective action of these antitoxins found in the serum. It is well-established knowledge today that active vaccination stimulates the antitoxins of cell antibodies, producing cells to full function. The development of an active vaccine took a few years. In 1913, Behring went public with his diphtheria protective agent TA, antitoxin. It contained a mixture of diphtheria toxin and the therapeutic serum antitoxin. So both. The toxin was meant to cause a light general response of the body, but not to harm the person who is vaccinated. In addition, it was designed to provide long-term protection. The new drug was tested at various clinics and was proven to be non-harmful and effective. During the first months of the war, this restraint led to massive losses of human lives. After the distribution of the tetanus antitoxins in the military hospitals, many futile attempts at therapy were noted. At the end of 1914, as a result of Behring's constructive assistance, the injection of serum was established as a preventing disease. Starting in April 1950, the mistakes in dosage and the shortage of supplies were overcome, and the number of sick fell dramatically. Behring was declared savior of the German soldiers and was awarded the Prussian Iron Cross Medal. It is known in that time that probably more soldiers died of sicknesses than by bullets or bombs or whatever other weapons there are. As again, it's only a summary in quotes from the article. The real article is longer and contains other information which I found in this case not to be relevant, but is interesting enough to read. Here you see the Nobel Prize diploma given to Emil von Behring, and this is a magnification of a part of it. Okay, as said, there is going to be another film about this subject, and it will be dealing with the Nobel Prize lecture Behring gave when he received the prize. Thank you for watching.